Hello dear friends, today we have a chapter 18. The topic is recursion. What does it mean? Why do we need the recursion? The recursion is defined some kind of function, or in the programming it is a method which is executed by calling itself several times. To understand this topic better, let us see the example of computing factorial. If you remember, what does the word factorial mean? Factorial is, let me take marker. Factorial is, let me change the color. Okay, when you have some function f at n. To find the f at n, you are always multiplying it with a number and with the previous function. Or simply, for example, n factorial is n times n minus 1, which is in the parentheses, times n minus 2, and etc. at the end times 2 times 1. This is what is called a factorial. Now, how to find the factorial using the functions? Using functions, we can find factorial so that we will multiply the meaning of the, the argument of our function as n to the same function, but for one number less than our argument. If, for example, f at n will be equal to n times factorial n minus 1. Also, one more thing we must know about factorials is such that factorial 0 is equal to 1, not equal to 0, because if this will be equal to 0, then every factorial will be equal to 0. Now, how this factorial will work, let us see. To compute factorial form, what do we do? First of all, we multiply 4 with factorial 3, and then we multiply 4 to 3, and we multiply it with the function of factorial to the argument 2. Then we change and write 2 times factorial 1, and then 1 times factorial 0. As you could understand, this is the last thing in our operation, because after it, what happens after it, everything becomes to the solution becomes easier, because here we will not have any functions. This part, after which your loop of recursion stops, is called a base. Base means the place after which your deconstruction stops. If you assume it as, for example, assume that you have a house. Here you have something that's it is base of your house, and here you have some breaks. Okay, now if you want to break your house, first of all you take the sail and then take the breaks, and the part which is the last in your house is called the base. Our base in this factorial is factorial 0, which is equal to 1. And after it, what happens? After it, we are finding all the meanings, so that factorial 4 is equal to 24. Or let us see the same thing by the trace of recursive factorial. Before I will explain you how the trace is working, let me explain you what is stack. In previous topics, when we were seeing how our programs work, we were using such thing like there is a pipe and you are putting some actions into pipe, and the first action that you entered in your pipe will go up, go out of this pipe first. And this works by the logic of first in, first out. But in Java we have a class that's called a stack. Why do you need it? What is the stack? Stack is some kind of class which works such way that first in, last out. It means you put here some object and you put next object and then next and last. To perform the actions from the stack, you cannot start from the first one, you start from the last one. This is how your stack works. Or simply, what happens? First of all, the main method will be located in our stack, and then factorial the space required for factorial 4 is is put it we put it to the stack. After it we put factorial 3 and then factorial 2 and then space for factorial 1, and at the end we put here space that is required for factorial 0. And so the factorial 0 is base. After it we stop returning the meanings, the values of our method, so that first of all we take away this factorial 0, and then we take away the factorial 1, 2, 3, 4, and at the end we take off the main method. This is how your recursive functions work and how we can see the stack trace of this recursive method.